Hi everyone. In this video of our machine learning using Python training program from ittoolstraining, we'll get the understanding about polynomial linear regression. In our previous two lessons, we have discussed simple linear regression and multiple linear regression. Here we will discuss polynomial linear regression. When your data is exponentially growing, your independent variable is exponentially growing on the basis of your independent variable. Your dependent variable, which is your y-axis, is exponentially growing on the basis of your x value, which is your independent variable. In those cases, we use polynomial linear regression. We have already discussed that when we use linear regression or multiple linear regression, when you see that the chart which you have plotted between your data set is polynomial in nature, we use polynomial linear regression. The equation is y equal to b0 plus b1 x plus b2 x to the power 2 plus and then bn x to the power n. That how many number of degrees of freedom you want to use, degrees you want to apply on your polynomial regression. You can see here. Your independent variable is only one variable. You can see, but we are every time you can see the slope value, the coefficient values are changing. And here we have a data where we have number of ice cream sales on the basis of device temperature. When device temperatures increases, the sales polynomially exponentially growing. Now let's perform the same using the same data set in our Jupyter notebook. Let's save this notebook as polynomial linear regression. Okay, and again we want to load data, so for that import pandas as pd. Data frame is df, where we want to load data from pd dot read excel from our excel file. Data we are picking from the same location, and if you want to read the data, let's df dot head, and you can see few records from here, number of ice cream sales and then daily temperature. And we have already discussed the kind of plot we have between these two variables is polynomial in nature, so we'll use polynomial linear regression here. Now let's define independent and dependent variables. Okay, now temperature is my independent variable, and on the basis of this we want to predict our number of ice cream sales. So x is equals to df dot ilog method will use here. All the rows we want to hold, and which column? 0th column, this column dot values. But what will happen, everyone, if you use only one column, this will become vector, and we never hold our independent variable as a vector. We hold it as a matrix. So here I will define, okay, start from the very first column, ignore the -1. Okay, so this is our independent variable. Now our dependent variable y is equals to, from our data frame, ilog is the method. Again we want to hold all the rows, and dependent we can keep as vector, that's fine. And we want to hold this value only our 0 first column values dot values. Okay, so here we have successfully defined our x and y, independent and dependent variable. Now in this, no need to split this. Let's perform the polynomial regression equation directly. First we will perform this on fitting model on linear regression. Okay, we will fit model on linear regression and polynomial regression on both. And for this we'll import from the sklearn scikit-learn library dot linear model, import our class which is linear regression. Lin is the object which is from a class linear regression. We'll use this function and we'll fit this object on our x and y variable. This thing we have already discussed in detail in our simple linear regression. So here we have first fitted our simple linear regression model. Next, from our sklearn library, from pre-processing, we'll import polynomial features is the class which we will use for polynomial regression, and the object is polyreg, which is equals to polynomial features, and we'll define that okay, on this object degree is equals to 2. You can use 3, 4 as per the type of curve you observe between your independent and dependent variable. On the basis of that you can define degree. Okay, what level of degree you want to apply on your object. And now we'll fit this object on x p, which is p stands for poly here. This is not ploy, let's spell this as polynomial, and this is poly. Reg is the object which we have created. We want to fit this object and transform this, fit and transform on our x variable. Okay, so we are fitting this on our x variable. Now polyreg dot fit using x underscore p, which is our x variable, and y variable. So here we have fitted linear model, and here we have fitted our polynomial model, everyone. When we get the polynomial equation on the same independent variable, we can fit linear regression equation also. Linear regression, where lin2 dot fit on xp comma y. So here we have fitted our model. Okay, now next what we want to perform, we have not executed these yet, so let's start one by one. And here we have a, now let's plot the same, plot the linear regression equation and polynomial equation using the same data set. Okay, so to plot we have to import matplotlib dot py plot as plt, and also we have to use the magic line which is matplotlib inline to render our data. Okay, and here plt dot scatter is the plot which we want to create, where using x and y, these are the original values and which we want to show in red color. Then we want to fit our line using the linear regression model. plt.plot, we are using x independent variable and y. Now using linear regression, lin.predict is the method which we use to predict the values using the x independent variable. And in which color we want to show? We want to show this in blue color. And plt.show. So this is linear regression equation we have used here, and we are showing the plot, and this is how the output is, everyone. If you want to give some other things like plt.x label, what values you want to show in your x label? These are the temperatures and these are the number of ice creams we have sold. So this is temperature and you can see X label is temperature. Similarly, plt.y label, which is number of ice creams we have sold, and you can see the y label also here. You can add this. You can add title also. Those all things we have already covered in our data analysis and visualization using Python classes. So this one we have plotted using the linear regression equation. You can see we have used lin here, lin object, not the lin2. Now let's perform the same on the lin2 object. So here let's plot the scatter plot now using polynomial equation. X comma y, and actual object we want to show again in red color, and plt dot plot, our x object is same, but this is lin2 dot predict using our polyreg dot transform is the method which we will use on our x independent variable. I think we have used one extra basis here, and we want to show this in color blue. And plt dot show. Saying plt is invalid. Let's discuss about this. What wrong we have done here? This is open. Okay, so we missed to close the predict here, and you can see we have a typo in predict. And this is polyreg, everyone. X shape is does not matching training shape. Let's check the shape of our x variable. Okay, the challenge is we missed here fit, so we have to fit first or this object, and then we have to transport on the basis of independent variable, and shift enter, and you can see here this is a polynomial curve which is a best fitted as compared to the linear regression equation, everyone. Okay, so this is the example which we have discussed right now. Here is a polynomial linear regression in this video. So till now in the regression we have covered simple linear regression, multiple linear regression, and polynomial regression. Thank you everyone. Have a nice day.